What do you mean by angle of elevation? See, angle of elevation, whenever we are talking about elevation or depression, there is another term called angle of depression. Whenever we are talking about elevation or depression, we always talk about it from the point of view of the observer, where the observer is standing. Just remember this, okay? So if you have an observer here, okay, and there's an object placed at an elevated position. This is your object that is placed at an elevated position. Then what is the line of sight of this observer? The line of sight of this observer is this, right? He is looking at this object. This is the line of sight of the observer.
Good morning, sir.
Good morning. Right. So this is the line of sight of the observer. This is your ground level where the observer is standing, or the horizontal, you may call it. Okay. And this is the perpendicular distance of the object from the ground. Okay. So we have joined this. Therefore, the angle of elevation is defined as the angle made. This is a line of sight, and say this is the horizontal. Is the angle made by the line of sight of the observer with the horizontal when the object is at an elevated position. Okay, when this object is at an elevated position, that is why it is called angle of elevation. Okay, whenever the object is at an elevated position, remember, then we find out
Good morning, sir.
the angle of elevation. Good morning. Okay, so therefore this is the line of sight, and this is the horizontal. Therefore this angle, say theta, is called the angle of elevation. So here theta is called the angle of elevation of the object of the object with respect to the observer. Okay, so this angle theta is called the angle of elevation. Because why do we call it the angle of elevation? Because the object is placed at an elevated position, or you can also say because the observer is looking at the object which is at an elevated position. Okay, let us now define in fact let's see an example from angle of elevation. Let's see this example. The angle of elevation of the top of a tower from the point on the ground at a distance 150 meter from its foot is 30 degree. Find the height of the tower correct to one decimal place. Now this is a very simple example to start with. Okay, just to make you understand the concept of angle of elevation. The angle of elevation of the top of a tower. Let's draw a tower first. Let's draw a tower. Have this as your tower. Okay. From the point of the angle of elevation of the top of a tower. Which one is the top of a tower? Let's say This is the top of a tower, A. Okay, and this is the ground level, B. So the question states the angle of elevation of the top of a tower from a point on the ground at a distance 150 meter from the foot. Let's say this is the B is the foot of the tower. At a distance of 150 meter from the foot of the tower, say this distance is 150 meter from the foot of the tower. There's an observer standing. There's an observer standing at a distance of 150 meter from the foot of the tower. And what he's doing is he's looking at the top. So this is your observer. Okay, and he's looking at the top of the tower. So which one should be his line of sight? This is his line of sight. He's looking at the top of the tower. It is given here that the angle of elevation of the top of the tower from a point on the ground 150 meters from its foot is 30 degrees. So clearly this angle is 30 degrees because this is your angle of elevation. This observer is looking at the top of the tower at A. Okay, so his line of sight makes 30-degree angle with the horizontal. Therefore, it's called the angle of elevation. So angle of elevation is 30 degrees. Question is find the height of the tower. Now finding the height of the tower is actually a cakewalk because see 30 degree, but if this angle is your theta, then this becomes your perpendicular, your class from your class 9 knowledge. This becomes your base, and this is definitely a right angle triangle. So this is your hypotenuse, right? And here we know the base. We need to calculate the perpendicular, right? And this angle theta is given. So what is the relation between theta? In fact, which trigonometric function or which trigonometric ratio relates theta, perpendicular, and base? We know that tan relates theta, perpendicular, and base. Okay, so we know that tan theta is equal to perpendicular by base. That means here we have tan 30 is equal to perpendicular is AB and base is, let's call this point C, BC. So tan 30 you know is 1 by root 3 and AB we need to calculate and the length of BC is 150. Therefore, what is the length of AB? It is 150 by root 3. This is the height of the tower. Now, because the denominator is irrational, we just rationalize it. Multiply numerator and denominator by root 3. So you get 150 root 3 by 3. You can cancel this. You get 50 root 3. Okay. So therefore, 50 into, root 3 is 1.732. It gives you 86.6 meters. This is the height. So what we have used here is we have used tan because we knew the length of the base here 150. Okay, and we needed to calculate the perpendicular. So we needed to find a relation between perpendicular and base given theta. This angle was our theta. So we knew that tan relates perpendicular and base. That is why we use tan. Next, what we define here is called the angle of depression. Now, what is angle of depression? Now, in case of angle of elevation, we had an object at an elevated position. This time the object, instead of being at a higher position or an elevated position, the object is at a depressed position, at a position below the observer. Okay, so let us say that I have object here. Okay, say angle of depression. Angle of depression. Let's say I have an object. This time the object is at a position below the observer. And let's say I have an observer here. And he is looking down towards the object. So this becomes his line of sight, right? If this is the line of sight, what is the horizontal? This line becomes your horizontal. Okay. Next, this is the perpendicular height of the observer from the ground level. And this is your ground level. Okay. So this is your ground level. This is your line of sight. Sorry, this is your horizontal. Ground level is also horizontal. This is your horizontal. This is your line of sight. The angle of depression is defined as the angle made by the line of sight of the observer. This is your line of sight. Line of sight of the observer with the horizontal. This is the angle that we are talking about. This angle theta is called the angle of depression. Of the object P, or simply the object of the object with respect to the observer. Okay, so this is what angle of depression is. Let's see an example from angle of depression. How to apply the concept of angle of depression. The question here is, from the top of a cliff, it is this. From the top of a cliff, 92-meter high, the angle of depression of a boy is 20 degrees. What is a boy? Anyone tell me what is a boy? Boy, the floating object in water. Okay, usually used for some shipping purposes, some sort of floating object in the river. So from the top of a cliff 92-meter high, the angle of depression of a boy is 20 degrees. Calculate to the nearest meter the distance of the boy from the foot of the hill. Let's see. Draw a diagram. Drawing diagrams in the exam is very important because half of the story here in your heights and distances is about diagram. If you are able to draw the diagram, you'll be able to solve very easily. If the diagram is given, no problem. But if the diagram is not given, then marks will be allotted for drawing the correct diagram also. So here is your cliff. Let's call the cliff AB, which is 92-meter high. Okay. The angle of
Excuse
depression.
me, sir.
Say, go ahead.
Sir, can I leave the meeting? I need to log in from my computer.
Who is this? Ritika?
Yes, sir.
Yes, yes, go.
Thank you, sir.
Okay, AB is your cliff, 92 meters high, and in here is your river, and here is your boy here somewhere over here, floating object in the river. Okay, so clearly your boy is your object here. Okay, and observer is observing from the top of cliff. So this is your boy. From the top of a cliff, the angle of depression of the boy is 20 degrees. Now, what is the angle of depression? First of all, observer is at A. He is standing at A and he is observing the boy at say C. Okay, so let's draw his line of sight first. So A is looking at C. This is his line of sight. Okay, what is the horizontal? The horizontal is this. Therefore, if his angle of depression is 20 degree, then this angle must be 20 degree, right? And this is your ground level or your horizontal also. This is also your horizontal or your ground level, whatever you choose to call it. Okay, so this and this is 90 degree. The question is calculate the distance of the boy from the foot of the hill. Which is the foot of the hill? B is the foot of the hill or the cliff. Okay, B is the foot of the hill or the cliff. You have to calculate the distance of the boy from the foot of the hill or the cliff. Okay, so how will you calculate this? First of all, you must observe that if this angle is 20 degree, these two lines are parallel to each other, right? Because both are horizontal. Therefore, this must also be 20 degree, alternate angles, right? Now, so once we have got this, say this is equal to theta, then this becomes our perpendicular. This becomes our base. Okay. So perpendicular is given to us 92. We need to find out the base, and this is our theta. So which trigonometric function uh, uh, relates perpendicular and base? Again, tan is the one that relates perpendicular and base. So we use tan. So we have tan 20 degree is equal to perpendicular by base. Let's write tan theta to start with. That means tan 20. Perpendicular here is AB and base here is BC. So tan 20. Look at the tables. You know how to refer to the tables. From the table, you find out tables will be provided to you in the examination. You will find out the value of tan 20, 0.3640. The length of AB is 92 and the length of BC we need to find. That means BC is 92 by 0.364, omitting the 0. Okay, which can also be written as shift 3 decimals to the right, 92,000 divided by 364. Now here there is nothing much to do except that you can cancel and you can divide directly. Okay, so you first cancel with what you cancel with 4. Now it does not divide any further. It does not cancel any further. So you simply divide this. That is 91. Long division method, class 2 knowledge, right? So you simply would divide this. Okay. So if you divide this, and you'll get 252.75 meters. This is what you will get. But the question here is find to the nearest meter. Calculate to the nearest meter. So that means 252.75 you have got. That means you can approximate this to 253 meters, correct, to the nearest meter. If it had been, say, 252.3, then we would have written 252. If it was 252.4, then we would have written as 252 only. Only if it is greater than 2, on the decimal side, if it is greater than zero point 0.5, only then we write from 252 to 253. Okay, so that is what this is. Any questions till this part? Now we come to two very important problems here. Or in fact, 90% of the problems will be based on these two figures. 90% of the problem from heights and distances will be based on these two. So if you understand these two problems well, you will be able to understand most of the problems from heights and distances. Look at this problem. From 2 points A and B on the same side of a building, the angle of depression of the top of the building are 30 degree and 60 degree. Angle of depression means now the observer is at the top of the building. That is, he is at an elevated position, and he is observing object at a depressed position, at a position that is lower than him. So from 2 points A and B on the same side of the building, the angle of depression of the top of the building are 30 degree and 60 degree. If the height of the building is 10 meters, find the distance between A and B correct to two decimal place. Let's draw the building first. This is your building. Okay. Uh, let's call this building AB. Okay. From 2 points A and B on the same side. Okay. A and B are two different points. Let's not call it AB. Let's call it PQ. PQ is your building. Okay. From 2 points A and B on the same side of the building. So you have, let's take 2 points A and B on the same side, this side. Let's call this point B. Let's call this point A. So these are on the same side. This is one side of the building. What is the other side? This is the other side of the building. Okay. So objects are on the same side. Two objects are on the same side of the building. And remember, the observer is at P. That is why the angle of depression is, no, the observer is at A and B, because the angle of elevations are given. Fine. So the observer is at A and B. Okay. If the height of the building is 10 meters, what is the height of the building? 10 meters. From 2 points A and B on the same side of the building, the angle of elevation of the top of the building. So the object is here. Since angle of elevation are given, so from A, someone is observing the top of the building, and from B also, someone is observing the top of the building. Okay. The angle of elevation of the buildings are 30 degree and 60 degree. Now this is your ground level or the horizontal. So from the points are A. So A corresponds to your 30 degree. So this is your 30 degree, and this is your 60 degree. Now sometimes you will get confused about which angle is 30 degree and which angle is 60 degree. Remember always that the further angle from Q will always be the lower angle. You can remember it this way. If we get confused between which angle will be 60 degree, which angle will be 30 degree, which one will be the higher angle, which one will be the lower angle, remember this thumb rule, that the greater the distance, the lower is this angle. That is how you can remember. So that means Q and A are much far apart from each other. Therefore, this one will be 30 degree. Since distance between QB is less than the distance between QA, therefore this one will be the higher angle. This is the way you can remember. Okay. So that is one part. Diagram is done. So now let us see what the question is. Find the distance between A and B correct to two decimal places. So you need to find this distance. This distance you need to find. How will you find? See, first I will find this distance. Next I will find this distance. And then I will subtract to get my required distance, this distance. Okay. So let us proceed to find the distances. So first of all, tan 30, because we know the perpendicular. Look at this, right, the bigger right angle triangle here. Look at this right angle triangle. You can see two right angle triangles. First is this right angle triangle. This right angle triangle that you see will help us in calculating this distance. Okay. And which trigonometric ratio should I use? I know the perpendicular. This is my theta. I know the perpendicular. I must calculate the base. And tan relates perpendicular and base. So therefore I am going to use tan. Let's use tan. So we have tan 30 is equal to PQ by AQ. We need to calculate AQ actually. Now tan 30 is how much? 1 by root 3. And PQ is given to be 10. And we need to calculate AQ. That means AQ is 10 root 3 meters. Keep it at this in this manner only, because we still need to work with it. Now we'll consider another right angle triangle. We'll consider this right angle triangle. Now we'll consider
Sir,
this. Yes.
sir, tomorrow we will submit a project, sir.
Yes.
Okay, sir.
So this is your, we'll consider this right angle triangle. Yes. So here again, this becomes your theta, and this becomes your perpendicular, and this becomes your base. So we know the length of the perpendicular. We need to calculate the base only. So we use tan once again. Also, tan 60 is equal to PQ by BQ. And tan 60 is root 3. PQ is 10 BQ. So therefore, what is BQ? BQ is 10 by root 3. Which if you rationalize the numerator, which if you rationalize the denominator, you multiply numerator and denominator by root 3. 10 root 3 by 3. So you've got BQ also. So therefore, you've got this length and you have got this length. Therefore, what should be the distance between A and B? Hence, distance between A and B, that is AB, is equal to AB is AQ minus BQ. AQ minus BQ. AQ we have calculated as 10 root 3 and BQ is 10 root 3 by 3. Let's simplify this a little further. Take 10 root 3 common. You get 1 minus 1/3. 10 root 3, take the LCM. 3 minus 1 by 3. 10 root 3 into 2/3, which is 20 root 3 divided by 3. And therefore, how to calculate this? Put the values 20 into 1.732 divided by 3. So this should come to 11.55 546. Which is equal to 11 point. We have asked the answer correct to two decimal places only. So since there is a 6 here, we add 1 to 4, round it off, 11.55 meters. Correct to two decimal places. That's it. I stop here for today.